So in our last video, I analyzed every equation in motion. Told you about the four equations: v equal to u plus at, s equal to ut plus half at squared, s equal to u plus v over 2 times t, b square equal to u square plus 2as. All these things are not crammed, they are things that we've gotten to understand so far. So I will write it again on the board. V equal to u plus at, s equal to u plus v over 2 times t, v square equal to u square plus 2as, and we have s equal to ut plus half at squared, where I said v stands for final velocity, u stands for initial velocity, a stands for acceleration, t stands for time. Take note of this point. And when a body is starting from rest, it implies that the initial velocity is 0. The body is going to rest, final velocity is 0. So today we're going to talk about something very much important, where we're going to analyze v, velocity. So we start with velocity. Now, velocity, is it a vector or a scalar quantity? Take note, velocity is a vector quantity, and a vector quantity has magnitude and direction. What does it mean to have magnitude? Magnitude has to do with size. That means velocity can be quantified. Yes. So that is the first thing. Now, velocity, the formula for velocity is equal to total distance. We can call it total distance, or call it displacement. We can call it displacement. So we don't say velocity is distance over time. No, we call it displacement over time. So there's a difference between distance and displacement. Displacement is a vector quantity, but distance is a scalar quantity. So we are saying velocity is equal to displacement over time. Displacement over time. And this displacement is represented as s over t. So we have said velocity is displacement over time. So take note of this valid point. Now, displacement is also a form of distance. Displacement is also a form of distance. So if we are expressing distance, normally in mathematics or in physics, distance is expressed in meters. Distance is expressed in meters. So we have meters. If we are going to be focusing our attention on time, if we are going to be talking about time, what will you call the unit? Seconds. Seconds. So the unit of velocity is meter per seconds. The unit of velocity is meter per seconds. Take note of this point. The unit of velocity is meter per seconds. Then we have, so we've just been able to touch three things now. The first thing we said, velocity's unit is meter per seconds. The unit of distance is meters. The unit for time is seconds. Now we have touched three things already. We have another one, force. Force. This is the name I was called when I was 7. Force, which is equal to mass times acceleration. Force is equal to mass times acceleration. Force is equal to mass times acceleration. So if we are going to be grouping this, it is m times a, or ma. So F is equal to ma. Force is equal to mass times acceleration. So the unit of force can be classified in so many ways. But before I talk about the unit of force, I have to talk about acceleration before I go back to force. So acceleration is the rate of change. Acceleration is the rate of change of velocity with time. The rate of change of velocity with time. So we are talking about change in velocity over time, which is v minus u over t. The rate of change of velocity with time. So we already know that velocity is meter per second, which is already here, meter per second. But now we are also dividing it by another time again, which is seconds. So meaning that the unit of acceleration is meter per second square. Instead of writing meter per second, we are now writing meter per second square, because these seconds will affect these seconds to give us meter per second square. So the unit of acceleration is meter per second square. The unit for velocity is meter per second. That is already settled. We have acceleration meter per second square. We have velocity meter per second. Then we have force, where I said force is equal to mass times acceleration. Now, if force is mass times acceleration, we have to understand what acceleration stands for. And what does acceleration stand for? Acceleration is meter per second square. If acceleration is meter per second square, we have to place acceleration into this. So we already said that force has so many units. And one of the units of force is Newton. Newton. So force can be represented as Newton. Newton. Isaac Newton. You understand? Newton. So now we've said force is measured, can be classified, or the unit is Newton. We also have to understand that force can also be taken using mass times acceleration. So if we are going to classify force as mass times acceleration, we are going to take note that the unit of mass is kilogram. The unit of mass is what? Kilogram. Times the unit of acceleration is meter per second square. Meter per second square. So meaning that the unit of force is kilogram meter per second square. The unit of force is kilogram meter per second square, or Newton. So we already have two units now. The unit is kilogram meter per second square, or Newton. That's already settled now. So I've given more than enough units. The first one, we said velocity, distance over time, which is meter per second. We said acceleration, meter per second square. We said force, kilogram meter per second square, or Newton. We also have acceleration due to gravity. Acceleration can be normal acceleration due to gravity, which is meter per second square. Now, if we are talking about distance, meters, time, seconds. If we are talking about walk. Talking about walk. If we are talking about pressure. Talking about walk, we are talking about pressure. We are talking about energy. We are talking about energy. Okay, so we are talking about pressure. So take note that pressure is equal to force over area. Pressure is equal to force over area. So if we are comparing force over area, the unit of force already is Newton. Unit of force already is Newton. So if we are comparing force over area, the unit of area is meter square. So the unit of pressure is Newton per meter square, or we can call it m raised to power minus 2. Newton per meter square. Work, we have pressure, we have impulse, we have momentum, we have so many of these equations, so many of these units. But take note that every unit has its own specification. So you need to know the units and know how to apply them. The first one, I talked about distance, which I said is in meters. I talked about time, which is in seconds. I talked about velocity, which is meter per seconds. I talked about acceleration, which is meter per second square. I talked about force, which is kilogram meter per second square, or Newton. I talked about pressure, which is force over area, which is Newton per meter square. Then I will also tell you, make sure that anytime you are solving any physics question, you should always write down the parameters. Make sure all parameters are written so you don't have any form of mistake at the end of the day. Everything matters. Listen and try to understand every physics question. They are not really challenging, they are not really problematic, but you have to make sure you understand. Another thing is there's a difference between a scalar quantity and a vector quantity. A scalar quantity has magnitude but no direction, while a vector quantity has magnitude and direction. That's magnitude and direction. And magnitude has to do with size. So examples of vector quantity, we have displacement, we have velocity, we have force, we have momentum, we have so many of these things. Then for scalar quantity, we have distance, we have time, we have so many of these things. Area, volume, all these are under scalar quantity because they have magnitude but no direction. So that is one thing to take note of. And don't forget the 4 equations of motion. These things are also very much important. And see you in our next class where we are going to discuss more on how to apply this physics.